I have no idea why I gave you so many questions. So, question 9, this is a partial fraction decomposition question. So let's try to factor this thing. So I'm just going to actually work with the fraction, then I'm going to throw everything back into an integral. All right, so if I have 1 over 2x cubed plus x squared minus x, I could factor this denominator as pulling out an x, 2x squared plus x minus 1. And this is going to factor. This is going to be a 2x and an x is going to be a plus 1 and a minus 1, right? So we have positive 2x minus 1x. Cool. All right, so then we can break this up into, right, since each of these are non-repeating linear terms, a over x plus b over 2x minus 1 plus c over x plus 1, right? Doesn't matter if you broke them up the same way that I did. If you didn't, all that's going to happen is that my a, b, and c are going to be different than your a, b, and c, but you'll get the same numerators for your fractions, right? So if you said your a was where I put my c and vice versa, you get the same number over x that I get, promise. All right, so let's clear out the fractions, right? If we multiply everything by the least common denominator, x times 2x minus 1 times x plus 1 on both sides. And we're going to end up with something that looks like this thing. So we're going to end up with 1 equals, right, these x's cancel. So we're left with 2x minus 1, x plus 1 times a plus b times x plus 1 plus cx times 2x minus 1, right? And now the fun begins, trying to find our a, b, and c values, right? So if we plug in x is equal to 0, we're going to cancel out, let me do this a few times. So if we plug in x is equal to 0, then all of these terms just go away. And we're left with 1 equals -1 times +1 times a. So a equals -1. If we say, well, let's let x equal -1, right? That's going to cancel out this term here. It's going to cancel out this term here. So we're going to be left with 1 is equal to c times -1. 2 times -1 is -2, minus another one is -3. So that's 3c equals 1. So if 3c is 1, then c equals 1/3. And then finally for our b term, right, we want to get rid of the 2x minus 1 so we can plug in x is equal to 1/2. And so that means this is going to go away. That means this is going to go away. And we're left with 1 equals b times a half. A half plus 1 is 3/2. So we're going to get 3/4 of b is equal to 1. So b is equal to 4/3. All right, so let's plug all of that stuff back in. All right, so we're going to get this is the same as the antiderivative. Our a value is -1. So -1 over x. Our b value was what, 4/3 or something? So we're going to get 4/3. So I'm going to break it up into a whole bunch of like little integrals. Actually, no, I'm not. No, I'm not. Plus 4/3, 2x minus 1. Plus our c value was like 1 or something, -1, I don't even know. 1/3. 1/3 of x plus 1 dx. All right, so -1 over x. This is going to be negative natural log of x plus 4/3, right? So a really, really good, helpful 1 over 2x minus 1. If I take this antiderivative, right? So this is going to be, if we say let u equal 2x minus 1, du is equal to 2 dx. So dx is 1/2 du. So this is going to be the same as taking the antiderivative of 1 over u with the 1/2 out front, du, which is going to be 1/2 natural log of u. We don't even need the constant here. So we're going to end up with plus 1/2 natural log of 2x minus 1 plus 1/3. By similar logic, we're going to get like the natural log of x plus 1 here. Plus a constant. So we can just kind of clean it up a little bit. Negative natural log absolute value of x. Those cancel to give me a 2 plus 2/3 natural log of 2x minus 1 in absolute values plus the third natural log of x plus 1 plus the constant. That is our antiderivative for question number 9.